Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Najwani Anissa binti Muhammad Sabri. So today I will present about the basic principle and function of gas chromatography. Okay, gas chromatography is the process of taking a sample and injecting into the instrument, turning the solvent and analyte into gaseous form, and then there is a separating of the mixture of compound into individual peaks that shown in the chromatogram. So there are two types of gas chromatography, which is gas solid chromatography and gas liquid chromatography. So in gas solid chromatography, the mobile phase is gas while stationary phase is solid. And then it is used for separation of low molecular gas, for example, air components, carbon dioxide, carbon monoxide, and oxides of nitrogen. While in gas liquid chromatography, the mobile phase is a gas, while the stationary phase is a liquid that retain on the surface as an inert solid by absorption or chemical bonding. The sample will be injecting into the instrument that enters a gas stream which transport the sample into a separation tube known as the column. Okay, so the various components are separated inside the column, and then the detector will be measure the quantity of the compounds that exit the column. The component more soluble will travel slower and eluted later, and while component less soluble will travel faster and eluted out first. So the gas carrier used in gas chromatography which helium or nitrogen. Okay, so the standard sample peak retention time and area are compared to the test to calculate the concentration. So, the function of gas chromatography is to separate or analyze compound that can be vaporized. So, the vaporization is the process of liquid change to gaseous form. This is the diagram of gas chromatography instrument. So it starts with gas carrier. So the gas carrier must be dry, free of oxygen, and chemically inert. So an inert gas is the gas which does not easily undergo chemical reaction. So, in gas carrier, the helium gas are common gas used in the gas chromatography instrument because it has larger range of flow rates and compatible with many detectors. And then the hydrogen, nitrogen, and argon also can be used in the gas chromatography as carrier gas. The next instrument is sample injector. In the sample injector, the vaporization chamber is typically heated 50 degrees Celsius above the lowest boiling point of the sample and subsequently mixed with the carrier gas to transport into the column. So, the sample will be flow into the column and thermostatic oven. So in the column and oven, the thermostatic oven serves to control the temperature of the column, which a few tenths of a degree to conduct a precise work. So gas chromatography column are usually between 1 and 100 meters long and form a helical shape. And then most applications run on capillary column. And then the sample will be flow into the detector. Detector is the device located at the end of the column which provides a quantitative measurement of components of the mixture as they elute in the combination with the carrier gas. Common type of gas detector are mass spectrometer, flame ionization in bracket FID, thermal conductivity in bracket TCD, electron capture detector in bracket ECD, and then atomic emission detector in bracket AED. So when the sample arrive at the detector will generate a signal and will be converted into a chromatogram. So we can see from the peaks in the graph of chromatogram. So that's all from me.
Hi, my name is Siti Zulaika binti Ishaq. So the advantage of gas chromatography is high resolution power compared to other method. It's shown by strong and symmetric peak. Next is high repeatability and reproducibility of retention time. Next is high precision and accuracy in quantitation based on peak area measurement. For example, no discriminations of component through volatility, polarity, and concentration. Next is analysis of sample very quickly, minutes, even a second. Next is small sample needed, microliter to microgram. Last, minimum thermal and catalytic decomposition of sensitive sample component. While disadvantage of gas chromatography is limited to volatile sample, not suitable for thermally labeled sample, sample dissolvable do not react with the column, and lastly is during injection of gases, sample proper attention is required. Thank you.
Okay, next, I will explain about the sample preparation of gas chromatography. Okay, first, there are 5 types of sample preparation: headspace sampling, distillation method, solvent extraction, solid phase extraction, and direct injection. Headspace sampling, there are 2 methods, which the direct space sampling, headspace will be taken from sample in closed vessel for direct injection into GC. Meanwhile, for dynamic, it will involve the purge and trap process, which sample is purged within the gas and then it will be retained by the absorbent or cryogenic traps. For distillation method, there are 2, which is steam distillation and simultaneous distillation and extraction. Steam, it will use steam at atmospheric pressure or in vacuum to heat and cold distill volatile from the sample. While SDE, product steam and solvent vapors will be intermixed and condensed. For solvent extraction, there are 3 types, which is simple batch extraction and continuous extraction. Basically, it will use the typically organic solvent with respiratory funnel to extract the analyte. And for solvent assisted flavor evaporation, which we call as SAFE, it will extract, the sample will be extract solvent which added slowly to the SAFE device. So volatile and solvent are distilled and collected in cold trap. So and then the next method type is solid phase extraction, SPE. There are 4 methods, which is sample solid phase extraction, SPE, solid phase dynamic extraction, SPDE, solid phase micro extraction, SPME, and stir bar subtive extraction. And then the last method is direct injection, which it will inject 2 to 3 microliter sample directly into the GC column for the preparation sample. So this is device for the method of sample preparation that I explained before this. So this is for headspace sampling, this for SDE, SAFE, SPME, and SPSE. So thank you.
In the sample preparation that Siti Shahmina mentioned just now, we will need the reagents for making the volatile derivative of components for the gas chromatography analysis. There are 3 types of reagents we can use. First one is the Sealy reagent. Sealy reagent is used for the food constituents such as sugar, sterol, and amino acid. We can choose either trimethylchlorosilane, BSA, and BSFA. Second one is esterifying reagent that can be used during the esterification process. We can use methylonic HCl, methylonic sodium methoxide, and N-dimethylformamide dimethylacetal. This one can be used for the food constituents such as fatty acids, amides, and amino acids. The last one is the miscellaneous. Miscellaneous can be used for the food constituents such as phenols, aromatic hydroxy groups, and alcohol.
There are three examples of the miscellaneous reagent, which is O-alkyl hydroxylamine, acetic anhydride, alkyl boronic acid. So we can use either three types of this reagent, depends on the types of food components that we use.
Okay, next we go to the output and analysis of gas chromatography. So from this scene, the individual peaks are shown preferably individual compounds. The output of this scene was production from the output of this scene was in ion forms. So the output recorded as a series of peak. Peak area proportional to mass of compound injected y-axis. Right here, the y-axis here. And then the peak time dependent on velocity through column is x-axis. So this one. The x-axis here show the amount of the time taken for the analytes to pass through the column and reach the mass spectrometer detector. While for the y-axis here, we just take the area behind we just take the area under the graph. So means that the reflection of the amount of specific analyte that's present, this area can be calculated automatically by the computer linked to the display. Okay, then further analysis of GC will continue mass spectroscopy, or as we know MS. As a result, three-dimensional area of data is obtained. So every point chromatogram contain mass spectrum, which is useful for characterizing the compounds. Then mass spectroscopy also provide information about the molecular weight and chemical characteristic of compounds. So compared to DC, mass spectroscopy is more better in terms of when to identify the functional group.